In 12.2, we had discussed how to find the surface area of a right prism and a right triangle. Them being right means that all of the lateral faces, or all of the sides as you guys would think, are intersecting the base at a right angle, meaning that they are perpendicular. And that's going to be the exact difference between 12.2 and 12.3, where we're going to have figures that have slanted sides instead of sides that are straight up and down. So we're going to be dealing with cones and pyramids in the next section. Now, to review a little bit on how to find the surface area of a prism and a cylinder. So if you have a prism or a cylinder, you have two identical bases. So you can find the area of the base. Depending on the shape that you have, you may have a triangle, so you may have to remember 1/2 base times height, or you may have a circle and have to remember pi r squared. So you find the area of the base and you put that into your formula. You have two identical bases, so that is why you multiply it by 2. And then the shortcut that they give us is, instead of finding the left side of this prism, and then the right side area, and then the front face area, they say that you can actually take the perimeter, of the base and multiply it by the height. So as you can see, I have three sides that are marked, a green side, a yellow side, and a blue side with the height. And if you were to look at the lateral area, it is actually just one big rectangle. And that's going to be the same with a cylinder. So you're going to take the perimeter of the base. In this case, however, since it is a cylinder, the perimeter of the base is 2 pi r. It is the circumference. Of the circle. So you're going to take the circumference of the circle, which is 2 pi r, and you're going to multiply that by the height in order to get the full surface area. Now let's continue on to 12.3. We are going to be discussing surface area of pyramids and cones. So our sides are no longer going to have right angles, so we're going to need to use some additional formulas to find some pieces of information, such as a height that we would want. Now, in a pyramid as well as a cone, let me draw a cone real quick, we need to think about a couple of parts that we have. So in order to find the surface area of these faces, I'm going to need the height of the triangle. Now, just strictly looking at that face, in order to have the base times the height of the triangle, I'm going to need to be able to find that height. Now, the height of that triangle is not the height of the pyramid itself. The height of the pyramid is a little bit different. So if I take this piece and actually pull it apart and put it on the side, you can see that it also creates a nice triangle. So sometimes you're going to be given the height of the actual pyramid itself, when in order to find the surface area, we need what is called the slant height. We need the slant height in order to find the area of the surface. Alright, so let's look at a way in which we can find the slant height if we are just given the height. If I choose to go ahead and chop a pyramid right down the middle from the vertex down to the base, I would be able to see this triangle that is formed on the right side as well as on the left side, if it is a regular pyramid and everything is nice and equal angular, equilateral, and so on and so forth. So if I see this and I'm given the height, let's say 15 centimeters, and that the base is 16 centimeters, I should be able to figure out what the slant height is, which the letter that they use is L, slant height. I guess the L for slant there. And in order to figure that out, I need to use the Pythagorean theorem, a squared plus b squared equals c squared. Keep in mind that the c is the hypotenuse, and that is the slant height that we were trying to find. So I'm going to go ahead and plug in h, which is 15, the height squared. Now the b is this part of the base here. However, the whole base is what I'm given. If the whole base is 16, and this being a regular shape, that means this is going to cut it in half, and those parts are going to be congruent. That means this is 8 centimeters. So this is going to be 8 centimeters squared equals my hypotenuse squared, which I can replace that c with L squared. And in order to solve this, I'm going to need to take the square root eventually of the right side, which means I need to take the square root of the whole left side. So L should be the square root of 15 squared plus 8 squared, which actually comes out to a really, really nice number. And that comes out to 17. This turns into the square root of 289 if you multiply it out and add. So that means my slant height is 17. So now I have a piece that I'm going to be able to use when I'm finding the surface area of, I now have this height and the base in order to find the surface area of that face. Now let's go ahead and see if we can work through a full example using what I just covered. So in this section, this is going to be dealing with all regular pyramids, meaning that the bases are going to be regular shapes, equiangular, equilateral. So in this case, the base looks like a square and is a square. So in order to find the complete surface area, I have one base. So I'm going to take the area of the base so far. So the area of the base is 40 times 40 feet. So I am going to get 1,600 feet squared. Alright, now I need to figure out all of the faces. So how many faces do I have and what the area of them add up to. Now the formula in the book on page 811 gives you this piece of your formula, 1/2 PL. The P standing for perimeter of the base, and the L standing for slant height. So right now the way it is, I have the height of the pyramid, but I do not have the slant height. So if I have the base and the height, I should be able to find, using the Pythagorean theorem, so I should be able to find the slant height. So this is 21, and this is half the base. So the base of this triangle is actually half of the base, so that means this is going to be 20. So if I use the Pythagorean theorem, a squared plus b squared equals c squared, which that's going to be your slant height, so I can replace that with L. That adds up to 841 for L squared, and in order to find what L is, I need to take the square root. So L ends up being equal to 29. So that means my slant height, right here, my slant height is 29. So I can now plug that in. So we do 1/2 because I'm dealing with triangles, and so if I have that base and that base and that base and that base, all times the same slant height, I do have to account for the fact that they are triangles and take the 1/2. So the perimeter here, 40 plus 40 plus 40 plus 40 is 160 times that 29. And that will end up feet squared as well. So then the total surface area should end up 1,600 plus 2,320 for a grand total of 3,920 feet squared. Since it is still an area, it is feet squared. So sometimes you might have to find the slant height by using the Pythagorean theorem. And one other thing I want to go ahead and discuss is, what if the base of the pyramid that you are trying to find is not something that we have discussed before? For example, we have discussed squares, and we have discussed triangles and even rectangles. However, what if it is a regular polygon that is more than 5 sides or 6 sides? Maybe it's a pentagon, hexagon, octagon. Let's discuss a formula in which you can find the area of the base of any one of those regular, meaning they're equilateral and equiangular, regular polygons. Now, no matter whether it's a hexagon, pentagon, or octagon, this formula will work. And here it is. So the area, I'm going to put A for area, is equal to 1/2, because we'll be dealing with triangles again, the A, apothem, times P, the perimeter. So perimeter, we are strictly speaking of all the sides, and since it is regular, they are only going to give you one side, and you would just multiply that by how many sides that you have. In this case, it is 6. So I'm going to fill in what I know. I'm looking for area, 1/2, and now the perimeter is going to be, in this case, 60, and the apothem is going to be 6.9 millimeters. I believe this is a part of number 7 on page 814. So the apothem, it looks exactly like a height would per se. The apothem connects the center of the polygon to the side and intersects it at a right angle. And it would do so if you drew the line to every single side. And the reason why we are dealing with triangles is because if you connect each vertex to the center, it would create a triangle. And we would technically be taking the area of all of these triangles and adding those up. So that is why we have 1/2, but instead of doing them all separately and then multiplying by how many triangles you have, we're just going to take the perimeter instead. So here the apothem is going to be 6.9 millimeters. So then you would multiply that out, and that's the area of your base that you would plug in. So this is the formula you need to know, whether it's 6, 5, or 27 sides. As long as it is regular, this formula will work. Now on to our last formula of the section. So we are going to be talking about cylinders as well, and if you make a pretty good assumption here, we're probably going to have to deal with the area of a circle and circumference again, so pi r squared into pi r. You can find this little proof in the work for this on page 812 of your text. So I'm going to go ahead and write out the formula for surface area of a right cone. Alright, so surface area equals the base plus 1/2 the circumference times the slant height. And if you chose to plug in your formulas, that's pi r squared, the base is pi r squared, plus pi rl. Now the question is where does the pi rl come from, and why does that replace the circumference times the slant height and the 1/2? The proof for that is above on 812. I'll just kind of explain exactly what each of these pieces gives you. So this right here is the area of the base. If I were to draw out the net, here's what the net would look like, except that I am not an artist. Alright, this is the base right here, and this is the lateral surface area. This is the lateral surface. So what you guys know is how to find the area of that circle. That's pi r squared. So that is that piece. It's the base. So that is all taken care of. Now the question here is, how do I find the area of this odd shape that looks like a Pac-Man getting ready to eat the ghosts? And this is the proof that you can see on page 812, where we actually set up a proportion between the area of a sector and the area of a circle, and then an arc length, which the arc length is a piece of the outside of the circumference over the full circumference of the area. And when we set those up, all the variables end up canceling out somehow, and we are left with pi rl. So let's work an example real quick. Alright, so this is checkpoint 3 and 4, or guide to practice 3 and 4 on the bottom of 813 that I'll be working through. So, in order to find the surface area of this cone, which, let me draw out my picture of the net real quick, I'm going to need to know pi r squared, and then I'm going to be able to set up a proportion somehow, and maybe I'll have to find the slant height as well in order to figure out what the total surface area is. So right away, let's go ahead and attack the base. Pi r squared, so let's fill in this piece real quick. Pi r squared, what is r? It is the radius, and it is 15 squared. So that means that this piece is going to end up equaling 225 times pi. Alright, now let's fill in the next piece. I am going to go ahead and use this piece down here in order to figure it out. Right now I'm just going to write pi, and I know what the radius is. It is still 15, but the slant height is a piece that I don't know, so I'm going to draw out my right triangle, and A is 20, B is 15, and I'm trying to figure out C. So A squared, 20 squared, plus 15 squared equals my slant height squared. And so I need to take the square root of that. So it's the square root of 625, which comes out to a nice even number of 25. So my slant height is 25 times 25. Now if I do the math, 25 times 15 is 375 pi. So that means when I add these together, I get a whopping total of 600 pi. And I'm going to go ahead and approximate and fill in 3.14 for pi and multiply it out, and I get approximately 1,884 yards squared. And that would be my final answer. And then I'll double check and see what they asked for. They asked for a surface area, and this gives me an area. Alright, we'll be going over this in class, and I will see you guys tomorrow.